And we've arrived at the last page of 4.1 notes, page 6. This is a 6-point overall assignment, so very beneficial. And more importantly, this is a section that is going to pay big dividends if we excel at later on. And I'm going to go back to talking about understanding formulas. Yes, we have memorized this formula. We have memorized the formula that circumference equals 2 pi r. We paid the price. That's probably fresh in your mind. You've used it so much. But we don't use the formulas we have here that much, so we can always build off of that. So when they say find the radius, we got arc length, we got central angle theta, we got r and s and theta, all of those things. Circumference, arc length, is a fraction of circumference, fraction of 2 pi r. I always start it that way. What fraction? Well, let's see, an arc length around to here. This is my arc length s, this is angle theta, this is r. An arc length, what fraction are we? Well, we're theta out of 2 pi. 2 pi's cancel. Oh, s equals theta r. And that's convertible. Let's see how we're going to convert this one. Find the radius r. Oh, I want to find r. Well, r is equal to, divide away theta, s divided away theta. Things to remember, this is a radian-based formula, so on 18, I got an extra step here because they didn't give me radians. So here we go. Can it be that easy? R equals S, our arc length, 3, divided by 4 pi on 3. That is 3 times 3 on 4 pi. That is 9 on 4 pi. There's our radius. Okay. Then 104, 8 inches, 330 degrees. Oh, I need 330 degrees. I need to cancel degrees. I need to introduce radians. Take a look. Reduce by 3, and I get 11/6 pi. So the radian measure is the arc length. Our arc length is 8 divided by 11/6 pi, or 11 pi on 6. That's 8 times 6 on 11 pi. That is 48 on 11 pi. And yes, the pi is in the denominator here. Alrighty. And here we go. Good little problems here. Find the distance between the city. Assume the Earth is a sphere of radius 4,000. I could have used my special circle drawing skills for that, but that's not too bad. Radius 4,000. And the cities are on the same longitude. One city is due north of the other. So we've got Seattle, Washington. Well, that one's been in the news lately. That's up 47, 37, 18 from the equator. I'm going to exaggerate that a little bit just to get some separation. So here's Seattle. And then we've got San Francisco. I guess I better do this. Seattle. San Francisco, that's not up as far. And again, I'm exaggerating some distances here. So here's San Fran right here. And we're supposed to find that arc length. But an arc length is theta r. Arc length is theta times radius. So our arc length formula we're going to use, arc length is theta times radius, or our arc length is radius is 4,000. Assume the Earth is a sphere, radius 4,000. Got it. Arc length is 4,000 times theta, and the theta we're looking for is right here. We need that angle measure right here. This is still 4,000. How am I going to find that angle measure? Well, that angle measure would be this angle measure minus, minus that angle measure. I take this angle, take away that angle, and I've got it. Take this angle down to here, subtract this back to there. So I want the big angle, I want 47 degrees, 37 minutes, 18 seconds, minus 37, 47, 36. I need to figure that one out. I'm going to let my calculator do that for me. Let's go. 47, and truthfully, I don't use degrees, minutes, seconds, but most students end up liking it, so I'm going to do it that way. I would go 47 plus 37 on 60 plus 18 on 3600 minus quantity 37 plus 47 on 60 plus 36 on 3600. But I'll go ahead and do this. So here we got 47 degrees, 37, second angle minutes, 18 alpha plus seconds minus 37, just for good measure. I don't think I have to do this. 37 second angle minutes, 47 second angle, did I say minutes for that first one? That was degrees, now minutes, and 36 alpha plus seconds, and I get 9.828, and right here we're in a little bit of danger because I'm going to say, oh, that's what theta is, so now I just need to put theta in here, and take a look what we're going to get. 30, if this was 10, which it virtually is, we'd get 40,000 miles between Seattle and San Francisco. How in the world can that be 40,000 miles and this just be 4,000 here? And I'm relative to scale. I mean, not exact scale. I mentioned that. So what's the problem here? This isn't 9.82 radians. This is 9.82 degrees. And we're going to use theta, or S equals theta times R, but that is a radian-based problem. So I get S equals radius 4,000. I like it, but times 9.828, or maybe better yet, ANS, times, that is a degree measure. I need to cancel degrees, and I need to introduce radians right here. So I get 4,000 times 9.828, but I think I'm going to go back, delete that, and use second answer, because there it is, better solution for me, times second pi divided by 180, and I've got, well, that seems a little bit more reasonable. I'm almost 700 degrees, San Francisco to Seattle, so 686.147 miles. Boy, is that easy to bypass, because we see this 9.828 come up and we're just like, hey, that's our angle measure. And we just want an angle measure, but it has to be in radians when we're using any of the formulas based on this, any of our three formulas. What are those three formulas for review? There's one, solve for theta. Theta is S divide R. Solve for R. R is S divide theta. But this is the one I know because it makes sense to me. That's the arc length is a fraction, what fraction? Theta out of 2 pi of the circumference. Okay, And there it is. I hope that section went really, really well for you. Let me know what I can help with.